Welcome to Romeo GH Studios. Today we want to look at how we can solve this question under the topic circle theorem. Now, from the diagram, we have been asked to calculate for the angle at Q. Now, and we have been also told that line PQR is tangent to the circle at Q. Now, there is a property that the angle between a chord and a tangent is equal to the angle the chord creates at the circumference. Therefore, since QN is a chord and this chord here meets the circle at Q, all right, which is tangent here, an angle of 58 is formed. So this angle, which is 58, is equal to the angle the chord creates at the circumference here. So the angle here is also going to be 58 degrees. Now with this angle and this angle, we can find the angle at Q. Let's see how we can do it. So we can say that our 58 plus our 46 plus angle, that is MQN, should be equal to 180 degrees, which means when we sum all the angles in a triangle, we must equate it to 180 degrees. So here we are going to have 104 plus our angle MQN equal to 180, all right? Therefore, our angle MQN is going to be 180 minus 104. Therefore, our angle MQN is going to be 76 degrees. So this is how we can solve this question. So simple. Thank you. Today, we want to look at how we can find angle PXQ from this diagram below. Now, if we critically look at the diagram, we can see that PQ is a chord, and this chord, which is PQ, subtends an angle at the center, which is O, all right? And anytime a chord subtends an angle at the center of a circle, it forms a triangle, which is triangle POQ. And that triangle is an isosceles triangle because from O to Q is the same as O to P. Now, what do we know about isosceles triangle? Base angles are equal. Therefore, if the angle here is 15, the angle here is also going to be 15. With this 15 and the angle here, we can find the angle at the center. With our angle here, we can also find the angle at the circumference, using the principle that the angle at the center of a circle is twice the angle at the circumference. Let's see how we can first get the angle at the center. Now, with our 15 plus the 15 plus the angle at the center here, which is angle POQ, must be equal to 180 degrees, which means when we sum all angles within a triangle, it must be equal to 180. So here we have 30 here plus angle POQ equal to 180, all right? So here we can say that angle POQ is going to be 180 minus 30. So angle POQ is going to be 150. Now that we know the angle at the center, we can get the angle at the circumference, where the angle at the center, which is POQ, will be equal to 2 times the angle at the circumference, which is PXQ, all right? Since we know POQ to be 150, will be equal to 2 multiplying PSQ. We divide here by 2, divide here by 2, and our angle PXQ is going to be 75 degrees. So this is how we can find angle PSQ in this diagram. Thank you. All right, today we want to look at how we can find angle BAO from this diagram below. Now, when we take a critical look at the diagram, we can see that line BC is a straight line in which O is the center, all right, which makes line BC to be a diameter. And we learn from the principle of circuit theory that a diameter subtends an angle of 90 degrees at the circumference of the circle. Therefore, the angle here is going to be 90 degrees. With we knowing this principle, we can also look at line AC. Line AC is a chord which subtends an angle at the center of the circle, which makes triangle ACO to be an isosceles triangle because AO is a radius and also OC is a radius. So two lines of this triangle are equal, which makes the base angles of the isosceles triangle also to be equal. So now that we know the angle here to be 41, with our 90, we can get the angle that is A. Let's see how we can get it. So first of all, we can say that is angle ACO should be equal to angle OCA equal to 41 degrees, all right? And we can also say that angle BAC should be equal to 90 degrees. Therefore, we can say that angle BAO should be equal to 90 minus 41. Therefore, angle BAO is going to be 49 degrees. So this is how we can find angle BAO from this diagram. Thank you.